Thank you very much for joining today's webinar, The Role of Inflector Insulators in a More Efficient World. Webinar is hosted by Energy Efficiency Done Right, a global energy conservation energy efficiency product provider. The presenters today are going to be Keith Roberts, the Vice President and Business Development Manager of Energy Efficiency Done Right, and myself, Dennis Roberts, President of Energy Efficiency Done Right. To share my background so you know my qualifications to present information on this important subject, I'd like to let you know I'm a 10-year energy advocate. I'm a consultant for Windows and energy efficient issues to Gerson Lerman Group and the TGI network. I serve in the National Fenestration Rating Council Task Force for Interior Attachment Ratings. I'm a published author on Energy Pulse. I'm an accredited lecturer on energy efficiency, and I'm a presenter to home and garden shows and professional groups on energy efficiency issues. I'd like to begin by talking about what we're going to be doing here. We're going to be showing you the nature of the problem today. And that problem today is Earth, we have a problem. Earth, we have a problem, and it's a large problem. The problem is resource use, resource distribution, and how we address these issues and how this affects our future. What you can see is energy. Let's first talk about how much energy is left. And let me tell you this, mankind is using energy resources at an alarming rate. Humanity would need 5 Earths to produce the resources needed if everyone had the lifestyle of Americans. As it is, humanity each year uses resources equivalent to nearly 1.5 times Earth's uses to meet its needs. This is an ecological footprint calculation from the Global Footprint Network. So right now we're using 1.5 times Earth to meet our annual needs. Putting it another way, each year the world uses the energy equivalent of 10,000 million tons of oil. 10,000 million tons of oil. Now let's look at what's estimated that we have left of our resources. Interesting enough, they're estimating 40 years left of oil, 60 years left of gasoline, 250 years left for coal, and 80 years left of uranium. Now what's most alarming about this is what we've got by far the most of is coal. And of course coal is what we're fighting for carbon emissions. We're trying to lessen our dependence on coal to have less carbon emissions. So this is a dangerous situation, the amount of resources left and what those resources are, primarily being the coal. If y'all remember, during the last presidential election, John McCain said, "Drill, baby, drill," as if the energy solution is through doing more drilling. But what experts say is this: U.S. oil production peaked in 1970, and we're going to see this exhibited even more in some other slides. This peak has never been exceeded despite the subsequent 38 years of technological improvement. Major events like the ramping up of the Alaska North Slope oil production and economic incentives produced by higher prices. From historical data, there is essentially zero evidence to suggest that even a very large increase in domestic drilling will bring substantial increase in energy returns. The United States is unlikely to ever gain enough new domestic energy supplies from ramping up drilling to significantly change its dependence on imported energy, not at current consumption levels. And you can see that's clearly exhibited here. Let's look a little bit at projected demands for developing countries. And this is another area of major concern. Developing countries are quickly growing their needs, they're still becoming industrialized. Well, as you look at across the different levels here, what you're going to see as time goes on, that the demand is actually increasing far more in the developing countries than the developed countries. And the dangerous thing that we're seeing here, as you can see, the purple being the coal. Notice the tremendous increase in coal demand as an energy source. Again, we're trying to reduce our dependence upon coal because of carbon emissions, and then yet the likelihood is very high that it's going to be demand is going to increase, use is going to increase. This actually is a regional share in energy demand as it is now and as it is going to be going into the future. This bottom area is actually the Organization of Economic Cooperation and Development. Well, this is 30 nations. Among those 30 nations is the United States, Canada, Australia, the UK, and as you can see, Japan and South Korea. 30 of the most developed nations in the world. Well, what's interesting as you look at this graph is that as time goes on, even though the energy demands of these 30 countries comprising the Organization of Economic Cooperation and Development is increasing, as a percentage of the global use, it's going down. So actually our say on energy issues is going to be diminished, and the distribution of the resources are going to be favoring other countries. So this is another area of growing concern. Here we're looking at production of projected world peak production of petroleum. And what I want you to notice is a few things on here. This brown line right down here, I've got my arrow pointed at, is the United States and Canada. Green being UK and Norway. This brownish line is the former Soviet Union. Well, interestingly enough, look at over time, what you're seeing is a far greater amount of world production as opposed to the production of United States and Canada, UK and Norway, the Russian countries. So what you're going to see is actually we have less say on world energy production, and we are more dependent on that production because most of our needs come from imports. So, and what that means is our energy dependence is diminished, our energy security is diminished, our dependence upon the other countries of the world, and particularly some of these countries that are not in stable situations that we're depending upon. Our energy security is very much in question. Another look at world consumption, and again this points out some dangerous situation in that you're still seeing this incline, stronger incline in coal. In fact, here is a major concern. The increase in coal is higher than the growth of renewables. So this is a primary concern. So what we have is a tremendous situation of diminishing resources and growing needs. And all of this affects our economic stability and our energy independence. So what are going to be our key challenges going forward? Well, those challenges are that fossil fuels are very unevenly distributed. And part of that uneven distribution is because of our use of our resources. So there are more resources outside of our control. Raw materials for generating energy are limited in scope for exports. We don't have a comprehensive energy policy. And remember, a lot of these energy sources are having negative environmental impact. So what we've got to do is make a change. So what I've been basically illustrating to you is, one, that there's a big gap out there. That gap is in the amount of resources we have available and the needs of the world. So we have to do something about that gap. Now the question is, what is the best source to come at that gap? Conservation and efficiency or alternative energy sources? I'd like to introduce Keith Roberts, Vice President of Energy Efficiency Done Right, and our Business Development Manager to discuss some of those issues. Keith Roberts.
Thank you, Dennis, for that great information. So just to reiterate what Dennis was talking about, alternative fuels are good, renewables are good, but it's not enough. Energy conservation and energy efficiency. Let's take a look at alternative sources. Wind turbines, solar panels, hydropower stations won't be built fast enough to keep pace with global electricity demand through 2030, according to the IEA. And when I refer to the IEA, I'm talking about the International Energy Agency, just for future reference. There will be a widening gap between power generated with renewable fuels and total consumption. This means coal-fired plants, which are cheaper and more polluting, will increase their share in the energy mix, discharging extra heat, trapping emissions that threaten the rise of the planet's temperature, according to the IEA. Burning coal will contribute 44% of power by 2030. compared with about 41% now. Let's just take a look at some of these alternative energy for it. We're going to analyze these alternative energy sources or renewables. Let's just take a look at the solar panels, what the payback period is. If you invest $75,000, what is the payback at? It's 76.9 years. Again, if you invest $75,000, a payback panel of a PV system at a 7.54 kilowatt system is 76.9 years. That's not too good. Let's take a look. If you reduce the size of that solar panel by 30% reduction in electricity through a $4,000 investment, what is the payback period on a $56,000 investment? 58.6 years. Now, let's take into consideration if you want to, at a 30% electricity use reduction, at a 3% year utility rate increase, you're going to invest that same $56,000. That investment is 3% compounded annually. The payback period is 34 years. Now keep in mind, this doesn't include the maintenance fees that are affiliated with solar panels, and as well, if they break down, the repair factor. Now keep in mind, we are not banging renewable energies. We're just telling you the payback period is a lot more. What we're reiterating is energy efficiency and energy conservation. Let's go to the next slide. Let's take a look at this. According to Mark Hittman from Consumer Affairs Advocate, solar panels take 100 years to pay back after installation costs. Solar panels are one of the least cost-effective ways of combating climate change, according to the Royal Institution of Chartered Surveyors. In the new guide of energy efficiency, RISC says that roof panels for heating water and generating power are unlikely to save enough for bills. And in a worst-case scenario, it could take anywhere between 166 years, but most likely with the gas bills, it'll take about 100 years. So that's anywhere between 100 years and 166 years in a worst-case analysis. Again, let me reiterate. We are not banging renewable energies. We're just saying that the payback period in itself is far lower. Energy conservation, energy efficiency is the way to go. So if you take a domestic mounted wind turbine, it'll take anywhere between 50 and 100 years to pay back. Let's take a look at another one. Wind energy from a residential payback period is 30 years. If you invest $15,000 at a payback of $500, it's going to take you 30 years for that payback period. On a commercial payback, if you invest $100,000 a year at a $5,000 division rate, the payback period is 20 years. So what does that mean? If we build, let's just take a look at that. Wind turbines, solar power panels, hydropower stations won't be built fast enough to keep pace with the global electricity demand through 2030, according to the IEA. Building nuclear power plants would set America back in the race against global warming. If the nuclear industry somehow managed to build 100 new nuclear reactors by 2030, nuclear power could reduce total U.S. emissions on global warming pollution over the next 20 years by only 12%. Only 12%, according to a new report. Generating failure, how building nuclear power new reactors would require an upfront investment of $600 billion. $600 billion. Money which could cut at least twice as much carbon pollution by 2030 if invested in clean energy. In contrast, energy efficiency and renewable energy can immediately reduce global warming. And I'm going to reiterate this one more time. We are not bashing renewables. The point is that in order to fulfill world energy demands, we have to do it through energy conservation and energy efficiency. All right. So let's just take a look at here. One moment. We're having a little technical difficulty. I appreciate your patience. 1 minute. Just bear with us 1 moment. Thank you so much for your patience, ladies and gentlemen. So what does that mean? That means that Inflector can be and is one of the best tools. So let's go through this. What do we have for the facts of life?